Imagine there is only one ticket left. Two people are looking at the screen and both click buy at almost the exact same time. Both requests reach the backend, both check the database and both see one ticket is available. Sound good? To solve it, the database itself needs to protect the important operations. The first approach is optimistic locking. The word optimistic means we assume that the two requests are changing the exact same record at the exact same moment will not happen very often. If a conflict does happen, one request can safely fail or retry. Instead of checking first and updating later, we combine the check and the update into one database query. The SQL update item, the set log is equal to stock minus 1, where ID is equal to 7, and the stock is greater than 0. Let's understand this one line at a time. Update item mean we wanted to change the item table. That stock equal to stock minus 1 mean we reduce the stock by 1. Where ID is equal to 7 mean update only item number 7, and this is the important safety condition. And stock is greater than should be 0. The database will update the row only if the stock is greater than 0. Now imagine request A arrive first. The stock is 1. The condition is true. So the database update the row. The result is one row affected. The stock becomes 0. The request is succeed. Then request B arrive. The stock is now 0. The condition stock is greater than is false now. The database update 0 row. So request B safely fails. No double sale. That's great. This is still protected by the database internally. The difference is that we don't hold a lock while the whole application process is running. The database protects only the sort update operation. That make this approach fast and efficient when conflicts are occasional. Now let's look at the second approach, pessimistic locking. Pessimistic locking assumes or that a conflict would be very serious. For example, in limited seat or an inventory or the payment app. Here we lock the database row before checking and changing. The flow looks like the request is start a transaction and lock row 7. The request B arrive and try to access the same row. Because the row is locked, the request B wait. The request A read the latest stock and create the order and commit. Then the lock is released. Request B get the row, read the updated stock and see oh it's 0 and it's rejected. The lock exists only inside a sort transaction. As you can see, begin, lock the row, check the stocks, create the order and commit. If something failed before the commit, the transaction rolled back to previous value. That protect the database from being left in a half-finished state. I use both of these ideas in my project. Imagine a tournament with 64 team slot. When a registration open, many captains try to register at the same time. For tournament registration, I use pessimistic locking. The backend first look the tournament capacity row, then read the latest number of available slot. Check whether a slot is available or not. Then create the registration, and after that all commit the transaction. The next request wait briefly and reads the updated capacity and either register successfully or get rejected. This prevents the tournament from accepting more teams than it allows. For tournament status update, the situation is a bit different. Many people may open the same tournament page at the same time. The stored status might still say upcoming even though the start time had already passed. For that case, I use optimistic update. The backend calculates the correct status and update it only if the old status still matches the what I accept. So the first request repair the stale value, other request receive the correct result without holding a long lock. So here is the simple thumb of rule. Use optimistic logging when conflicts are uncommon, speed matters and the failed update can safely be rejected or retry. Use pessimistic logging when conflicts are likely or when double booking would be a serious problem. The frontend cannot solve this problem by itself. The database must protect the important operations. Because concurrency is not only about speed, it's also about keeping the data correct. If you learned something useful, like the video and subscribe for more backend and system design breakdown. And tell me in the comment which locking strategy would you use for your project. And thanks for watching and see you in the next one.